Alright, let's look at the corollary of theorem number 1. Alright, so again, we have two half planes, H1 and H2, determined by line L. Alright, so if point B is in H1, it's one side of the line L. L is this guy right here. And F is on the other half plane in H2, right? A and G are on the borderline, and A and G are separate distinct points. Then segment GB and ray AF has no points in common. Right? So let's prove that. Alright, so here are the givens. B is in H1, F is in H2, and A and G are on the line L, and they are distinct. Right? Number 4. Right, by theorem 1, we know that half open, half closed segment GB, right, is going to be entirely inside H1. Right, so this is using the fact that number 1 and G is on the line, and then theorem 1. Right, and on line number 5, by again theorem 1, we know that open ray AF, right, is going to be entirely inside H2. Right, so I'm using the fact that F is in H2, so line number 2 and line number 3 with theorem 1. Right, so since it's a corollary of theorem 1, we should use theorem 1. Alright, so then if you remember H1 number 1, so H1, actually number 2, H1 number 2, half planes have nothing in common. Right, so therefore 6, if you intersect the half open, half closed segment GB and intersect with AF, right? And this is going to be contained in the intersection of H1 and H2, but there's nothing in common, so this is an empty set. So we know that the intersection is going to be an empty set. So I'm just doing combining number 4, number 5, along with H1 part 2. Alright, then we know that since there's only one point missing, G is on the line, so adding G, so I'm going to just say, so therefore, right, adding G to this is not going to create an intersection point because Z is on the line and open segment AF is entirely inside H2, so there's not going to be an intersection. Alright, then I'm going to add A to it too, so it's going to be a ray AF, right? So it's not going to create any intersection point because A is going to be on the line. Only problem that could happen is A and G happen to be the same, but we know that the A and G are distinct points. So we know that this is going to be still going to be an empty set. So we're using the fact that line number 3, A and G are separate points, and combining with line number 6 to get that. Alright, that's it. I hope that this was clear.